Welcome to Kandela IAS. I am Shobha GC and today we will do a session on environment. The topic we have chosen for today is carbon sequestration and carbon sinks. So if you have seen our video on biogeochemical cycle for carbon, you will be aware that about carbon reserves and the methods of carbon emission. So if you see the carbon reserves, the largest stock of carbon reserve is found in the lithosphere in the rocks. Other than that, it is the oceans which forms the next highest carbon reserves. So carbon is stored in the lithosphere and in the ocean, and it is not a big impact on the climate. But when this carbon enters the atmosphere, then there is an impact on the climate. So let us see why there will be an impact on the climate. Carbon, as we know, is a greenhouse gas. What do we mean by greenhouse gas? Carbon traps heat during daytime. The heat that is released from terrestrial radiations of the earth. This heat, when trapped by carbon dioxide, helps earth to be warm. So it helps in the survival of life. So carbon becomes an essential gas where it is essential to maintain optimum temperature of the globe so that life can survive. Now, when this carbon is in the atmosphere and its levels are increased by human interference, that is by anthropogenic activities, then it starts creating an impact on the global temperatures. It starts trapping more heat and global temperatures increase. When there is this increase in global temperature, we call this as global warming. Global warming gradually causes climate change. So this climate change today has been impacting the entire globe from the poles to the equator. It is impacting the snow-covered regions, it is impacting the tropical regions, deserts and every part of the earth. However, the largest impact is on the oceans. So there is no part which is not impacted by global warming. So global warming and climate change have become a very big challenge which we are unable to reverse. So there is necessity to now act on these carbon emissions. Okay. So when we see carbon in the atmosphere, carbon in the atmosphere is present dominantly as carbon dioxide. And you are all aware of what are the different methods of emission of carbon dioxide. So carbon dioxide is majorly released by emissions from your vehicles, that is by combustion of fossil fuels. The other major emission is by combustion of coal, which is done to generate energy in thermal plants. So these are some of the popular methods where your human activities are releasing carbon into atmosphere, and this carbon is in the form of carbon dioxide. Industries release carbon dioxide, wildfires, forest fires, or burning of any type of vegetative matter releases carbon dioxide. Respiration releases carbon dioxide, but respiration is a natural process which does not have that huge impact when compared to these artificial methods by human beings. So, carbon emission into atmosphere in the form of carbon dioxide is by fossil fuels, industries, thermal plants, etc. There is another form of carbon dioxide in the atmosphere that we call as methane. Methane now is released by anaerobic respiration. Methane is especially released from agricultural activities like paddy cultivation, animal husbandry, And most popularly these days, we see an increase in methane emission from the tundra belt. Tundra belt is a region which has frozen ice and permafrost. What is permafrost? Permafrost is frozen soil. Soil is bound together by ice to form a thick, hard layer of soil. As the global temperatures increases, soil starts becoming loose. Why? There is melting of ice. Ice was acting as a binding agent. Now, because of increasing temperatures, ice melts to water and soil starts flowing along with this water. So, when soil flows with this water, the methane that is trapped underground starts releasing. So we are seeing that because of melting ice caps and glaciers, there is irreversible amount of methane being released into atmosphere. So these two are the dominant types of carbon that are being released into atmosphere. Until now, the priority was on to reducing the amount of carbon dioxide. But from 2022, even methane has been prioritized as there is large scale increase in amount of methane in the atmosphere. So our focus will be on reducing both the levels of carbon dioxide and methane, which have been responsible largely for global warming. So when we see the impact of methane and carbon dioxide on atmosphere, we can notice few things. So please follow the slide. So if this is Earth and this is the outer cover of atmosphere, carbon dioxide and methane are present in atmosphere. So what is the role of carbon dioxide and this methane in causing global warming? Are both the gases greenhouse gases? Yes, both the gases are greenhouse gases because they contain carbon. So you can see carbon is here and carbon is here. Since both are present, it is a greenhouse gas. When you see the impact of carbon dioxide and methane and you compare the features of both carbon dioxide and methane, carbon dioxide traps less heat, whereas methane has capacity to trap 25 times more heat. So heat trapping capacity of methane is definitely larger when compared to carbon dioxide. Then until now, why did we prioritize on reducing carbon dioxide and not methane? Because the half-life of carbon dioxide is somewhere close to 100 years. That means the amount of carbon dioxide that is present today in the atmosphere, for it to reduce by half and escape from the atmosphere, it takes around 100 years. Whereas on the other hand, methane's half-life is just around 9 years. So the amount of methane that is present in the atmosphere reduces by half in 9 years time. Hence, because of your longer half-life time of carbon dioxide, we had prioritized carbon dioxide and we wanted to reduce the levels of carbon dioxide in atmosphere. So the focus was completely on carbon dioxide. But today, the amount of methane is considerably large and the impact it is causing is large because you can see here that it efficiently traps 25 times more carbon when more heat when compared to carbon dioxide. Hence, there is prioritizing of both carbon dioxide and methane reduction. So, next, the process now where you try to reduce this carbon dioxide and methane, that is carbon from the atmosphere, is known as your carbon sequestration. So carbon sequestration in simple words is nothing but trapping atmospheric carbon. Very clearly it is atmospheric carbon. We are not trying to trap the carbon present in the oceans or the carbon stored somewhere else. We are trying to reduce the carbon present in the atmosphere. So we have to efficiently capture this atmospheric carbon and then put it in a place, store it in a place for long term so that it is not released back into atmosphere. This process of capturing and long-term storage of carbon is known as carbon sequestration. What is the result? The amount of carbon dioxide in the atmosphere will reduce. So this is our idea behind carbon sequestration. Carbon sequestration now, when you have to do it, there are two main types of carbon sequestration. So one of the methods of carbon sequestration is, so carbon sequestration can be done by two methods. So we'll see what are the two methods of carbon sequestration. So very quickly, carbon sequestration is capture of carbon dioxide from atmosphere and storing it for long time in a sink. So this is your carbon sequestration. So now this can be done by two methods. So one of the methods is geological. Geological means you're storing the carbon in the lithosphere, that is the rocks and underneath layers of earth. The other method is biological, where you store carbon in living organisms. So first, let us see biological sequestration methods. So biological sequestration methods, when you look around you, the cheapest, best and the most efficient methods of carbon sequestration is growth of plants. Why? Plants do photosynthesis. So we are aware of the equation of photosynthesis. Let us just quickly look at it. CO2, 6 CO2 plus 6 H2O in presence of sunlight and chlorophyll gives C6H12O6 plus 6O2. So you can see that plant is converting carbon into starch or glucose. And this glucose is stored in the plants. So C6H12O6 meaning 6 atoms of carbon have been stored in the plants. So plants trap this, store this, and until there is growth of plant and the plant is not cut down, it is stored in the body of the plants. So this makes it one of the most efficient ways to store carbon. Upon that, it is not easily released back into atmosphere. So wherever we see green cover is nothing but carbon stored in the plants. So this is known as biological sequestration of carbon in the forests or in the green cover. Now, your plants do photosynthesis during daytime. So what are plants doing during night? So during night, plants are also doing respiration. So if plants are doing respiration, they are taking in oxygen and giving out carbon dioxide. But does it mean that it releases all the carbon dioxide that is stored in the body of the plant? No. It only releases half the amount. The other half the amount is stored in the body of the plants. In fact, it stores almost 2 times the amount of carbon it releases. So the carbon stored in the body of the plant is much more than it releases during respiration. Plants are responsible. Plants meaning it includes your forests, grasslands, shrubs, etc. All the entire green cover that is present accounts for almost 25% of carbon sequestration. So growth of plants, trees, etc. helps in trapping carbon from atmosphere, and this is the cheapest and the most efficient method to trap carbon dioxide. Let us look at other methods of biological sequestration. The other method is your soil. So how does soil help in carbon sequestration? So if you see, any dead biomatter is buried. Biomatter meaning plant or animal is buried. This burial of plant or animal means that plant or animal contains carbon dioxide. It has carbon in its body in the form of starch. So there is carbon present in the body and the body is buried after death. And if there is stagnating water in the soil, stagnating water will slow down your process of decomposition. So when there is slowing of process of decomposition, carbon remains trapped in the soil for a longer period. So this type of trapping of carbon in the soil gradually leads to either formation of coal or your fossil fuel. It depends on the other factors like the nature of water that is stagnating. So there is incomplete decomposition or slow decomposition of dead matter creating fossil fuels in the soil. So this method efficiently helps in reducing the amount of carbon in the atmosphere by not releasing carbon after the death of plant or animal. So the places where in soil you can find this type of carbon sequestration are the bogs, peat and swamps which have stagnating water. Peat here you should remember is the first stage of formation of carbon. Carbon that is coal. First stage of formation of coal is peat. So this is another method of biological sequestration. One is growth of forest. The second one is the soil. The third biological method of carbon sequestration is the oceans. So let us now look at the third method of biological carbon sequestration. The third method of biological carbon sequestration is into the oceans. So how do oceans help in carbon sequestration? So if you see, ocean is in contact with atmosphere at the surface of the ocean. So carbon dioxide present in the atmosphere can directly enter into water. So there is direct exchange of carbon from atmosphere to water and from water back to atmosphere. This process now is creating a type of equilibrium in the atmosphere. How? Whenever there is excess carbon dioxide in the atmosphere, oceans absorb the excess atmospheric carbon. Whenever there is a kind of deficiency of carbon in the atmosphere, it is released back. So this crucial role of buffering of carbon is being done by oceans. Oceans now, when they absorb this carbon dioxide, they create a sink by dissolving carbon dioxide. How do they dissolve carbon dioxide? Carbon dioxide is dissolved in water readily to form carbonic acid. And this carbonic acid is trapped in the water for a long period and it is easily not released back into atmosphere. So when you look at it in the long term, lots and lots of atmospheric carbon is being absorbed by the oceans and is converted into carbonic acid where it is being trapped in the oceans because it has to maintain the equilibrium of the level of carbon in the atmosphere. We are releasing carbon to atmosphere and atmosphere is transferring that carbon into oceans. This is increasing the acidity of the oceans. Oceans help us in doing carbon sequestration, but when it is in large scale emission of carbon to atmosphere, oceans absorb excess carbon and turn acidic, which impacts it negatively. So oceans, when you see them, they store almost 25% of the carbon that is emitted into atmosphere, making it one of the largest carbon sinks. And carbon is stored in the ocean in the surface layers. It is not stored deeper inside and it is present in the surface, meaning it can release back into atmosphere whenever there is a deficiency of carbon. So these are the three popular biological methods of carbon sequestration, that is growth of forests and green cover. Second one being storage in the soil. Third one being the oceans, which have direct exchange of carbon between atmosphere and the water. So other than this, there are few other methods where you can do carbon sequestration. And one of the method is geological carbon sequestration. The other methods that we are talking about is man-made methods, where human beings are trying to put an effort in reducing the amount of carbon that is already being present in the atmosphere. So the term geological itself tells that it is storage of carbon in the lithosphere. So you have to now trap carbon and store it in the lithosphere of the earth. So when we see these geological methods, there are three popular methods. One being geoengineering, second one being carbon farming, and third one is the Carbifix project. So let us see what is geoengineering. Now carbon is present in the atmosphere which has to be trapped. So the first process here is trapping of carbon dioxide. So you have to trap carbon dioxide that is present in the atmosphere. How do we trap it? An easy method is to trap carbon dioxide using scrubbers. Wherever there is large scale emission of carbon. Like for example, your thermal industry, thermal industry, cement industry, and other type of industries. So at the place of generation of carbon as a waste, if we efficiently use scrubbers, we can trap carbon. This carbon now has to be sinked deep inside the layers of the earth. So where do we store them? We store them in mines, which have gone extinct, means they are now hollow and it is deep inside the earth. So efficiently we can put carbon into these hollow regions of extinct mines, and it can be trapped there for longer durations and is not released back into the atmosphere easily. So this is one of the methods of geoengineering where we are trying to do carbon sequestration in the lithosphere of the earth. Another method of geoengineering carbon sequestration is by trapping atmospheric carbon. So atmospheric carbon has to be trapped. It has to be compressed, liquefied, and liquid form of carbon is stored in the mines which have been extinct. One such application that we are seeing in the recent times is this liquefied carbon is being stored in the oil fields which contain oil. So what is the advantage of trapping or storing this liquefied carbon in the oil fields? When liquefied carbon is stored in the oil fields, it helps in increasing the liquidity of crude oil. When liquidity of crude oil increases, it helps in easy extraction of oil from oil fields. Hence, this has become one of the popular methods today in geoengineering, where liquefied carbon is being deposited into oil fields. So carbon can be stored in the form of solid as ash, etc. in your extinct mines, or it can be liquefied and it can be deposited or stored in the oil fields. So these are the two popular methods of geoengineering where we are trying to do carbon sequestration in the deeper layers of lithosphere so that it is not released back into the atmosphere in a short time. So let us see the other method. The other method is carbon farming. So what do we mean by carbon farming? So I think you are aware about your surroundings, that whenever there is fire in the vegetation or whenever there is a volcanic eruption, there is lots of ash, and ash is a natural fertilizer. So it helps in increasing the fertility of the soil. So you have soil, and this soil is agricultural field. So in agricultural field, we trap carbon in the form of ash or in solid form, and we spray carbon in the top layer of the soil. So when carbon is sprayed in the top layer of the soil, it has two advantages. One is it increases the water retention capacity. Water retention capacity of the soil is increased, and it also increases the fertility of the soil. In this process, we are not trying to store carbon deeper inside the agricultural fields. It is being stored in the top layer of the agricultural soil. So this acts as an added benefit to the farmer along with carbon sequestration. So this is carbon farming. So let us see the other method where we are trying to do carbon sequestration. The other method is Carbifix project. Carbifix project is an initiative where carbon dioxide is dissolved in water. So when carbon dioxide is dissolved in water, it forms a weak carbonic acid. This carbonic acid is now sprayed on the rocks. So when you spray it on the rocks, carbonic acid reacts with some of the chemical components of the rocks. Examples such as basalt. And when it reacts, it forms stable compounds. And these stable compounds are stored in the rock for a longer period. So this type of storage of carbon in the rocks is known as Carbifix. The project is an initiative by Iceland and already has been started in Iceland, where they are trying to dissolve carbon in water and spray them on the rocks and store carbon in the rocks. So this is another method of geological carbon sequestration. So we have seen three methods of carbon sequestration through geological method. The first one being geoengineering, where we are storing carbon in the form of solid or liquid in the empty or in the extinct mines. The second is carbon farming, where we are spraying carbon on the top layer of the agricultural soil, where carbon is absorbed by the plants and it is used as a fertilizer. Carbifix project is a project where we dissolve carbon dioxide in water to form carbonic acid, and it is sprayed on the rocks, and it gets converted into a compound which is trapped in the rocks. So these are the different types of biological and geological methods of carbon sequestration. So carbon sequestration, when we see it, it is popularly called as CCS. What is CCS? CCS is carbon capture and storage. So the initiatives we have been taking up to reduce carbon in the atmosphere is reducing the amount of carbon that is there in the atmosphere. So one is reducing the emission itself. So reducing the emission itself will create less damage to the atmosphere, and there will be a controlled level of carbon in the atmosphere. The other method we are trying to do is carbon sequestration, where carbon is being trapped from the atmosphere and is being stored. So this process will reduce the already present amount of carbon in the atmosphere. So we are trying to trap carbon dioxide largely, because half-life of carbon dioxide is around 100 years. So sequestration is one of the necessary methods where we try to reduce the amount of carbon present in the atmosphere. So for this, first we need to capture the carbon dioxide present in the atmosphere and then store it for longer time. So there are three steps. One is capture of carbon dioxide. Second, transport it. And third, store it deep underground. Capture, transport, store. Capture can be easily and efficiently done at the place of generation of carbon, that is the industrial section. And in industrial section specifically, carbon is released in large scale in thermal energy plants, steel industry, cement industry. So trapping carbon here makes it more efficient and it can be transported to the places where we do geoengineering. So CCS is a type of geological carbon sequestration where we capture it and store it. Another method of CCS is your biological sequestration, where we capture carbon and store it in the plants. So afforestation is a method of carbon sequestration, CCS. So afforestation programs have been taken up under the initiatives of Government of India, United Nations, etc. So next let us look at other different initiatives. In other different initiatives, the one being most popular and efficient is Carbon War Room. Carbon War Room is a NGO under the leadership of Sir Branson. It was his initiative to start Carbon War Room. So what is Carbon War Room? After the glowing concern of climate change, there was awareness created regarding this. By this awareness, Sir Richard Branson took up an initiative where he said that the new coming technology or the upcoming technology must be in a way where there is less carbon released. So low carbon economy must be planned and must be designed. So whenever there is a new technology or there are already existing industries, they must do research regarding their industries to reduce the amount of carbon that is being released. Carbon is mostly released from thermal plants and the transport industry. Transport industry includes rail, road and maritime transport mechanisms. Transport sectors, thermal energy sectors are the largest emitters of carbon. So whenever these industries are concerned, Carbon War Room makes sure of research and development in these sections where they reduce the amount of carbon. For example, if you are aware of Hyperloop, that is nothing but a method of transportation in a tunnel. So when we transport goods or it can be movement of people in a tunnel based train system, then the energy efficiency is very high. When energy efficiency increases, less carbon is released into the atmosphere. So such initiatives and such research programs have been taken up by Carbon War Room. So Carbon War Room makes sure that any developing technology does not cause more harm to the atmosphere by releasing carbon. So this is one of the other initiatives that have been taken up in reducing the carbon impact. Now, we capture carbon and we store carbon. The place where you store carbon is called as a carbon sink. If plants store carbon, then plants are also sink. Any place that stores carbon is a sink. So carbon, when it's stored in the ground, it becomes a geological sink. When carbon is stored in the plants, it becomes a green sink. And carbon, when it is stored in the ocean, it becomes a blue sink. So as we are aware that almost 37,000 gigatons of carbon is stored in the oceans, we should know that blue sink is one of the largest forms of carbon sink. So carbon sequestration is done and carbon is stored. The place where carbon is stored is called as a carbon sink. There is always some type of seepage from the sinks. For example, if you see from the plants during respiration at night, carbon seeps back into atmosphere. From the sink of the lithosphere, there can be some cracks through which carbon seeps back into atmosphere. Oceans, I told you that carbon is stored in the top layer of the water and it seeps back into atmosphere. So there is always some seepage back into the atmosphere. But the amount of carbon that the sink stores is much higher when compared to the amount of seepage. So though they emit some amount of carbon, they store lots more carbon when compared to the emission. So it makes the place an efficient place to store carbon and it is called as a sink. So carbon sinks are green sink, lithospheric sink and your ocean sink, which is a blue sink. So when we see around us, growing green sinks are the easiest and the cheapest forms of developing carbon sinks. So let us see in some other future lectures regarding this method of carbon sequestration of storing carbon in the green sinks. Hope this information was informative and see you in the future lectures. If you have any queries, do get to us on our social media. Thank you.